Let's talk about the difference quotient. The difference quotient is a topic that you're going to cover heavily in calculus. You're going to come back to it and you're going to use it in really cool, robust ways. We're just simply introducing this topic now here in pre-calculus. So before we can talk about the difference quotient, we need to talk about a concept called the average rate of change. The average rate of change, which I am abbreviating, where's my pointer? I'm abbreviating as AROC because it is shorter. The average rate of change of a function over an interval is the average change in the function's output when the x values increase by 1. So, for example, if I tell you that the average rate of change over an interval is 2, then what you can assume is that on average, whatever function it is that you're looking at, it'll go up by 2 units every time x increases by 1. Now, if this is a line, this makes a lot of sense, right? Like, we know lines have slope. So if I tell you that the average rate of change is 2, it would make sense that the slope of this line would be 2, right? I go up 2 over 1. And in fact, the average rate of change for a line is simply the line slope, because everywhere on a line, the change is the same. It's always going to go up and over a certain amount. However, if we look at functions that aren't lines, like this generic function down here, it looks a little bit different. So that's an awful rectangle. I've already restarted this video 3 times. We're not restarting it again. So we're just gonna keep going. So the average rate of change when I'm looking at a function that's not a line is gonna look a little bit like this. We take 2 points, all right? We take 2 points on the graph and we limit the function to a certain interval. So this interval that I'm looking at right here is the interval from A to B. Starts at x value A, ends at x value B. The slope of this line connecting this point right here and this point right here, the slope of that line is the average rate of change. This point, this line right here connecting these 2 dots is also known as a secant line. I'm not going to go any further than just saying that, but I'm going to throw it out there. It's good to know that terminology. The slope of the line connecting 2 points on a graph is the average rate of change. This is telling us, so you can tell that this is a positive slope right here, right? So it's telling us in general, that the function is increasing as we change our x values to the left, right? As we increase x in general, y is increasing. Not sure what the slope of this random line is, but if the slope of this line was 2, I would be saying that in general, on this curve, when you go over 1 x value, you go up 2 y values. Now, the thing about averages is that it doesn't give a full story. And the wider this interval gets, the less of a story it tells for us. Because what if this thing just went like this? If it went like, if I widened my interval and made my slope look like this, I would have an average rate of change that's almost 0, because the place I start and the place I end have very similar y values. But that, when I tell you the average rate of change is 0, you wouldn't expect to see hills, right? This thing increases and then decreases and then increases again. You wouldn't expect to see that when I tell you that the average rate of change is 0. So the average rate of change is really useful when we're looking at smaller intervals. The smaller we make our interval, the more impactful and meaningful that average rate of change is. In fact, looking here, if we limit it down this much, that average rate of change line is almost overlapping with my graph. So it's going to be very accurate for smaller distances, smaller intervals. Just going to put that back to where it was. The formula for the average rate of change. Well, we have 2 points on a graph. We have this guy, right? Let's use a different color. We have this point right here. We have this point right here, right? So point 1 is a comma f of a. F of a is the y value at point A, because this is a generic graph. Our second point is the point B comma f of b. Our slope formula is y2 minus y1 over x2 minus x1. Okay. So if, let's do a little labeling, let's say x1, y1, x2, y2. y2 is f of b. y1 is f of a. All over x2 is, oops. Hold on, let my screen readjust. Okay, there we go. X2 is b, x1 is a. So that slope comes down to be f of b minus f of a over b minus a. This is really the difference in the y values. So f of b minus f of a is this distance in y values. Difference in y values. Okay, we're just going to write vals. And here on the bottom, b minus a, that's this distance right here. That's the difference in x values. X values. All right, and I have that formula written down right here. F of b minus f of a over b minus a, when we're looking at the average rate of change over the interval a to b. So let's do a quick example. Find the average rate of change for the function f of x equals x squared plus 2x minus 3 over the interval 0 to 3. So our a value, because this is the interval a to b, our a value is 0. Our b value is 3. The formula for average rate of change is f of b minus f of a all over b minus a. If b is 3 and a is 0, this becomes f of 3 minus f of 0 all over 3 minus 0. F of 3 and f of 0 we get from plugging in 3 and 0 to this function. So let's go ahead and do that over here. F of 3, plugging in 3 for x, we have 3 squared plus 2 times 3 minus 3. Let's say we have 9 plus 6 is 15 minus 3 is 12. So f of 3 is 12. Minus f of 0 is plugging 0 into that function. 0 squared plus 2 times 0 minus 3. That's just negative 3. And then simplifying 3 minus 0 here at the bottom, that's just 3. Okay. So f of 3 is 12. F of 0 is negative 3. 3 minus 0 is 3. Here we're going to have 15. So 12 plus 3 is 15 divided by 3, which is 5. That's our final answer. That's our average rate of change between the values 0 and 3 on the graph of f of x equals x squared plus 2x minus 3. So that's how average rate of change works. We're here to talk about the difference quotient. And the difference quotient is the average rate of change, but over an arbitrary interval, as opposed to being over a a defined interval. So this arbitrary interval, x comma x plus h, I wonder if, can I have this duplicate, or is it going to try to duplicate everything? Okay, we won't do that. We won't do that. Let me just erase some stuff on here. There we go. So what we're saying is that we're going to start at some generic x value. We're going to go over a generic distance, let's say h. And that means we'll be ending on the value x plus h. If we start at x and move over h, you'll end up at x plus h. We're looking at creating a function that allows us to input any x value and any h value to find the average rate of change. This is nice when we write it like this because it is generic. I can start my interval anywhere and end it anywhere, and I can use the same average, I can use that same equation multiple times. So if we use the average rate of change formula over this interval, let's say average rate of change, that is f of b minus f of a all over b minus a. Here, a is x. B is x plus h. I am plugging those into this formula. This is going to make my difference quotient. So this is f of x minus f of, oops, boop, 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 boop. Not f of x, a is x, b is x plus h. F of x plus h minus f of x. All right, this is that top portion, f of b, that's f of x plus h, f of a, that's f of x, and then b, x plus h, minus a, which is x. Right, so let me do a little additional highlighting here. Boom. There's not much simplifying, come back here. There's not much simplifying you have to do here because we don't know what the function is. So we can't do any more than say f of x plus h minus f of x. But on the bottom, x plus h minus x, those x's cancel and you just are left with an h. And that, my friends, is the difference quotient. F of x plus h minus f of x all over h. So you're not given an interval. You are just taking a function, and this is the formula for the difference quotient. Let's see how this works out. Now your instructions on ALEKS are always going to be to simplify completely. So that is not a written instruction that I have here, but I'm going to assume that it is. So find the difference quotient for the function f of x equals 5x squared minus x minus 6. Right, so we're looking for f of x plus h minus f of x all over h. H is an undefined thing, by the way. We're not plugging in any values for x or for h. We're not plugging in any values for x or h. So first of all, this f of x part is already taken care of because f of x is 5x squared minus x minus 6. We already know what f of x is. We don't know what f of x plus h is. So we need to find f of x plus h. F of x plus h comes from plugging x plus h into this function. Right? In general, functions work like this. Whatever's in this box goes in all these boxes where you see X's, so I can replace the X with like a box and then just fill in the blanks. So I am putting X plus H into these boxes here. So this is 5 times X plus H quantity squared minus X plus H minus 6. I'm going to simplify this before I plug it back into the equation. X plus H quantity squared, that's going to be the same thing as X plus H times X plus H. I'm going to distribute. So we have minus X minus H minus 6. If you FOIL X plus H times X plus H out, you will get X squared plus 2XH plus H squared minus X minus H minus 6. Almost there. And then I'm going to distribute this 5. We get 5x squared plus 10xh plus 5h squared minus x minus h minus 6. Whew, okay. Nothing combines together. That's as simple as that one gets. So this is our f of x plus h. That goes right here. F of x will go here, and then we'll just simplify. So I'm taking this whole thing here, duplicating it. In fact, I'm gonna need to pull everything down because it's gonna get crowded. So this right here is f of x plus h. This minus is this minus. F of x is 5x squared, make sure you use parentheses, minus x minus 6, all divided by h. We are going to distribute this negative, and then we are going to simplify. So we have 5x squared plus 10xh plus 5h squared minus x minus h minus 6 minus 5x squared plus x plus 6, all divided by h. Things are going to simplify. So there's a 5x squared and a minus 5x squared, so those cancel. There's a negative x and a positive x, those cancel. There's a 6 and a positive 6, those things cancel. So what you're left with here, did I get everything? Let's see. I think we're good there. You're left with 10xh plus 5h squared minus h all over h. With these difference quotient problems, this h in the denominator will always find a way to cancel, right? It'll always get canceled out. And if it doesn't, that means the math went wrong somewhere. But I'm gonna make a note here. With difference quotient problems, the h in the denominator will always cancel. For this guy, I'm going to factor the h out in the numerator. So we have 10x plus 5h minus 1 all over h, and then those h's can cancel. You're left with 10x plus 5h minus 1. And that is your difference quotient for that function. So it's not a number. Average rate of change is a number, but the difference quotient is not a number. This is a function that you can use. You can say what x value you want to start at, how far you want to go, plug in those values. Now, we're not going to do that. I'm not going to go any further with it than this. But in calculus, what you're going to do, because it's pretty interesting, in calculus, what you do is you make this interval get teeny, teeny, tiny, so tiny that it comes to the point where the average rate of change is actually the instantaneous rate of change. And that is how quickly the graph is changing at a particular point, not over an interval, but at a particular point. So that's what calculus goes into. That's not for us. Let's do one more example. Let's do it with a rational function so that we get some practice with that. And then you'll be good to go. Again, the difference quotient, that's f of x plus h minus f of x all over h. What you're going to find for these ones is that really the difficulty comes in the algebra, 100%. F of x is already taken care of right here. We have f of x. It's good to just be plugged in. F of x plus h, on the other hand, we get that from plugging in x plus h where we see x's here. So f of x plus h is equal to, instead of x in the numerator, x plus h, and instead of x minus 3 in the denominator, it's x plus h minus 3. Boom. So we have f of x, we have f of x plus h, we can plug it in here, and then we're going to have to do a bunch of algebra. In the previous problem, the hard algebra really came from plugging in x plus h. In this problem, plugging in x plus h isn't difficult. It's just that the math afterwards is tedious. All right. So this is going to be a nasty looking fraction. So this is f of x plus h minus f of x is, put the denominator down first, x over x minus 3 all over h. You are now tasked with simplifying this fraction. This is a complex fraction. We have some issues here because I said that the h has to cancel, and like it's not going to cancel in the form it's in now. So we're going to have to do a significant amount of work. There's different ways of doing it. I'm about to teach you one way. It's up to you whether or not you use this way or you simplify your fractions another way. One thing that you can do, you can take this big fraction here, because we have a big fraction. This is the fraction of the big, this is the numerator of the big fraction. This is the denominator of the big fraction. Within the big fraction, we have two smaller fractions. I can take the denominators of these two fractions in the numerator, and I'm going to multiply on top and bottom of the big fraction by both of those denominators. All right, so I am multiplying. I will end up multiplying both of these fractions by x plus h minus 3, this denominator, and times x minus 3, that denominator. And whatever you do in the numerator, you're going to need to do in the denominator. Boom. I have not changed anything because I did it in the numerator and denominator. As long as I do it to both, I have not changed anything. This entire thing gets distributed to both of these guys. I normally don't write this math out, but it can be useful the first few times to write it out so that you see what's happening. And I'm only doing one example of this, so I might as well. All right, so this guy right here, if I duplicate him, boom, boom, boom. I'm going to put his numerator in parentheses. I have distributed to him this guy right here, right? This gets distributed to him. I'm going to put the denominator in parentheses so that the canceling makes sense. This minus sign right here comes down here. This guy here boom, boom, boom. I am also taking and distributing this to him. So distributed, putting the denominator in parentheses so that the canceling makes sense later. This big line that I'm drawing is the big fraction line here. This stuff all comes down here. I'm just going to make it black. Bam. And move it down just a tiny bit. Once again, I am trying to simplify this complex fraction, so I'm multiplying both of these fractions in the numerator by this ends up being the LCD of these two fractions. When I do that, here's the fun thing that happens. I get some stuff that cancels. X plus h minus 3 cancels over here. On the other side, x minus 3's cancel. What I'm left with this x plus h. He's still there. I'm left with this x minus 3. They are still there. Minus, that's the same minus. These guys. That's all that's left there. And then the denominator. This looks nasty, but I'm going to give you a hint. I'm going to give you a hint. The hint, my friends, do not ever FOIL out this denominator. All right, don't FOIL it out. You can FOIL out the numerator, but don't touch the denominator. Leave the denominator alone. It's in the form it needs to be in to make the h cancel. So just leave it alone, but FOIL the numerator. So FOILing this guy here, x times x is x squared. X times negative 3, negative 3x. H times x, that's xh or hx, it doesn't matter. Right, so I am FOILing right here. This is what I am doing right now. And then h times negative 3 is negative 3h. This right here is that. Minus, I'm distributing this x to everybody. So I have x squared plus xh minus 3x. I could have distributed the negative while I was at it. That would have made my life a lot easier, but I didn't. So we'll do it on our next step. Leave the denominator the same. It's really easy when you're doing it on an iPad. You can just copy and paste stuff. It's so much nicer than doing it by hand on paper. It gets real tedious. All right, I'm distributing this negative sign. So I have x squared minus 3x plus xh minus 3h minus x squared minus xh plus 3x all over the same denominator we've had all along. Looking at things that cancel, these x squareds cancel. We have a negative 3x and a positive 3x, and those cancel. We have a positive xh and a negative xh, and those cancel. And in fact, all we're left with in the numerator is negative 3h. In the denominator, we're left with this entire thing that we've had the entire time. And now that h in the denominator can finally cancel, right? We have an h in the numerator, h in the denominator. We're going to cancel, cancel, and we are left with our final answer, which is negative 3 all over x plus h minus 3 times x minus 3. And that is my final answer. Genuinely, genuinely, the hardest part of these difference quotient problems is going to be the algebra, right? If you were unable to follow the algebra that's going on here, you might want to refresh yourself on algebra. There are resources available in our Canvas shell. If you go into, I think it says Math 95 review, or it might say algebra review. Forget what I named it on my page. Doesn't matter. You can find resources online to help you pick up on your algebra, refresh those algebra skills. This is really important to be able to follow this algebra because as we get farther and farther into our pre-calculus material, these algebra skills are going to become more and more vital. So do be sure that you're comfortable with everything that happened here. If you have questions, send me an email. Otherwise, that is what you need to know about the difference quotient. Most importantly, that the difference quotient is this formula. And then it's just algebra from there. All right, I'll see you in another video. Bye.